Need it? I'm recording. Start this one off. We're moving into trigonometry. I've got another book for you. But I asked you to do this for homework. How did we get on? Yeah.
I didn't understand, but I just want to live to prove that I actually did it in my computer.
So you did something different. So you quite over that one. Okay. How about you, Sam? No? So no? Okay. Alright, let's go through it then. So I said to you that this was a trapezium. Alright. By the way, if you have looked on your review guide for the mock e-assessments, you'll have noticed that trapeziums come up on that list, right? Areas of trapezium. So this might be a good one to like, oh, I get that. So trapezium, but we're doing Pythagoras' theorem. We want to know this orange length, but we're doing it, remember I said the first thing to do in a question is identify the triangle, which we did by adding a line. Remember we talked where could it go? There were some other options to get the right angle triangle, but this was the one. Why was this the one? Well, that gives me a part of that side is something I can work out. Now, this part, however, is not part of the triangle. But do I know this length? This bit? What is it? That's just 2.1. How do you know that? Yeah. Parallel to the other one, it is a rectangle. We've got 90 degrees there. So we know that this side, that's a bit dark. So this side here and this side here are the same length. I also know that this side and this side are the same length, hence I knew that that was 1.9. Now this is the triangle, all right? So now we do need to identify my a squared, my b squared, and my c squared. So which is the a, the b? Well, the first one to do is which one's the c?
But 3.2 is.
Yeah, that is the c, because it's the longest side of this triangle. Okay, so small one, slightly bigger, biggest, if we're still doing this. So this will be 3.2 squared, which is 10.24. Okay. Which one's A and B?
A.
You're going with A is 1.9. Okay, so this will be 1.9 squared, which is
3.61.
3.61 plus the question mark. So this is the question mark squared here. So let's do that. So we've got 3.61. This is B plus B squared equals 10.24. And what do we do then? Subtraction. So B squared is 10.24. Subtract 3.61 and you get 6.63. Now what do we do? Square root. So B is the square root of 6.63, which is 2.5. Okay, so I think this one is 2.5. Just checking, does that make sense? That's 2.1, 2.5, 3.2, 1.9.
Wait, how did you read that?
Square root of 6.63?
Wait, so basically just C minus.
C squared minus A squared in this case. Okay, the same thing we've done repeatedly in the last couple of lessons. Yeah, there's nothing new here other than the initial setting up the triangle. Once we've got the triangle, everything else is the same. There is one final step though, which is adding them together. So I'm happy that 2.5, it's not much different to that, but remember it's not to scale, but the numbers look about right, so I'm happy. So my final step is that BC, the line B to C, is going to be 2.1 plus the 2.5, which gives me an answer of 4.6. Now, there is a problem here, which is give your answer to correct 3 significant figures. So I'm going to suggest that some rounding happened that shouldn't have happened. Because this is only 2 significant figures and it asks for 3. What is the actual square root of 6.63?
2.57.
2.574. Okay, so actually I should have 2.574, which would make it 4.674, which would then allow me to write 4.67 with my 3 significant figures. So big thing, don't round too early. All right, we should write that down. Sorry to any other question.
So,
No, because it's 5 or more, isn't it? So the 4 we just... So what we want is, I've asked for 4 significant figures here because I want to end up with 3. So we go for 1 more than I need and then we round. So if the 4 is not enough to make another 1 in the next column, we just ignore it. So grab it. If it was 5 or more, we say it's enough to add it on to the next column. Yeah. Get it right now?
I didn't
Where did you go wrong?
know. The form.
We are going to do now is we are going to look at another thing to do with right angle triangles. It's trigonometry. It's still right angle triangles. So first off, we are going to, again on the front cover, write down what we are going to be using. So there's a lot to remember with trigonometry, and I will offer you, I think, exactly what I did in M3. It's exactly the same thing. We did it then. We're doing it again now. The same exam strategy. Now, trigonometry, again, must be a right angle triangle. That's all we're using it for, right? But trigonometry compared to Pythagoras' theorem is now we use angles. Okay? Not just sides. Now, again, I'm not going to go into all the details. I remember doing this with you in M3, and it's probably still on my YouTube channel of us doing it. All right? You can go back and think about why this works, because we have already talked about to do with similar triangles and that kind of thing. So I'm just going to remind you of what the trigonometric ratios are. So if you remember that. So, with trigonometry, what we do is if we know one of the angles. Now, do you recognise that symbol, what it's called?
It's not a degree symbol.
It's not a little zero, no. It's actually the Greek letter theta.
Okay.
It's like an O with a line through the middle. Okay, it's called theta. and it's another Greek letter we use to represent angles. Okay. Now, with trigonometry, with a right angle triangle only, we are looking to name certain sides. So not just A, B, and C this time. We have what's called hypotenuse. We have an adjacent side, and we have an opposite side. Do you remember this?
Remember hypotenuse?
So the hypotenuse is C from before, the longest side. All right? That's always the hypotenuse. And just like C before, it's the one that is opposite the right angle. Any ideas where you think which sides are the opposite and which one's the adjacent? So, any ideas which the adjacent would be?
The line that's the hypotenuse, the angle
Say that again.
is the adjacent to the line, and then the hypotenuse, the angle. If that's
Okay, so the hypotenuse is this side.
yeah.
The adjacent side is actually the one that is next to the angle. The angle is the angle. These are sides. So we have an adjacent side, we have an opposite side, and the hypotenuse is the longest side. Right? So obviously that leads us to understand that this side, in this case, is the opposite, because the angle and the side are opposite each other. Do you know what the word adjacent means? Opposite means across from. Adjacent actually means
Next to.
adjacent. Actually, well, a door can be ajar, not adjacent. Adjacent actually means next to. Yeah. So Marley is sat adjacent to Sienna and Eden. So can you understand why this side is adjacent to the angle?
Yep.
Yeah, because it's next to the angle. It's the one that makes the angle with the hypotenuse. The opposite side is the one that's away from the angle. It's opposite. Okay. Got that? But that can change. Any ideas why? So if I went for the other angle, the adjacent and the opposite would switch. But the hypotenuse is always the same, always the longest side. So these two depend on which angle is used. We've only got two to choose from, but that's number one task in trigonometry, is to decide which one is the hypotenuse, which one is the adjacent, which one's the opposite. Just like with Pythagoras' theorem, you had to get C right. Well, in this case, you have to get hypotenuse right, but you also have to get the other two right. It's not like either or. These times, you have to do it. So, tip number one. Now, how do we use this knowledge? Well, we can say, because of, and again, I'm not going to go through this because we've done it before, because of similar triangles, and you can look that up if you've forgotten, okay? I can say any triangle with the same angles, okay, will have the sides in the same given ratios. Now you might remember those as the opposite divided by the hypotenuse. Hypotenuse is one of those ratios. The adjacent divided by the hypotenuse is another one. And the opposite divided by the adjacent is the third one that we consider. Now, ratios are just division. Okay, it's another name for division. So, opposite divided by hypotenuse, adjacent divided by hypotenuse, opposite divided by adjacent. Okay, so what I've just said there is if you have triangles that have the same angles, they can be different sizes because they're similar triangles. It can be bigger or smaller, but if the angles are the same, those ratios will be the same, and we can use that information. All right. Now, do you remember what those ratios are called? They were given names. There it is. These ones. So I will tell you the first one. The first one is sine of theta. Is that one. So sine of theta is just the name given to that ratio. On your calculator, you will see it as sin. It's actually read sine and it has an E on the end. And we actually should say it as sine of theta. Now what that means is, if I know the angle, I know what the ratio needs to be. Do you remember what the other one is?
COS.
So cos is actually called cosine of theta. Third one? Tan? Know what it's called? Tangent of theta. I'm not giving myself much room. I hope you've got some more room, but I didn't. So, what we do is we simplify how we write all that, and we say sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, tan theta equals opposite over adjacent, which I remember as SOHCAHTOA. You remember that? I just remember SOHCAHTOA because it sounds like Krakatoa, the volcano that exploded. Some people have rhymes like some old hags came and had tea one afternoon. Sailing, something to do with sailors and catching things off Afghanistan and all that kind of stuff. I don't know. I just remember SOHCAHTOA. Some people write SOHCAHTOA like that. Some people write it as SOHCAHTOA to remember it's a division instead. Up to you how you wish to remember it. Lots of info, like I said. Once we've gone through a couple of examples, hopefully that'll make sense. On there. It's going to be on the video, you need to finish off the notes. Right, so we have a right angle triangle, so it means we could use Pythagoras' theorem or trigonometry. Looking at this diagram, how would you know it's trigonometry, not Pythagoras' theorem? Yeah?
It says 36.
Exactly. When there's an angle, that's a good sign that it's trigonometry. All right? So what do we do first? Well, this is how I answer my trigonometry questions. My first step is to write down SOHCAHTOA. Okay? My first step is to write down SOHCAHTOA. Because I need to get that bit right. And then I'm going to write theta, opposite, adjacent, not a D, an A, and the hypotenuse. And I am going to, on my diagram, make sure I've identified those things correctly. I'm not going to skip this step ever. Okay, because this is how I make sure it happens. So theta, I now look at my diagram and I decide, do I know theta or is it what I want to know? What do you think? We know it, and it is 36 degrees. So I'm going to write theta is 36 degrees. All right, the opposite side. Now I need to decide which one's the opposite side. So look at the angle and go opposite it. This is the opposite side. Now it's saying to me, work out the length of BC. That is the opposite side. So that's the one I'm going to call X because it's the thing I want to know. Does that make sense?
Yeah.
So I'm going to call my opposite, that is my X. What's the adjacent side? This is the adjacent, right? Because it's next to the angle, right? So that's my adjacent side. So I'm going to write adjacent equals
8.7.
8.7. And then finally, this is the hypotenuse because it's the largest side. Do I know it?
No.
Do I need to know it? So I am going to cross that out because I don't care about hypotenuse in this question. All right, make sense? So I've already eliminated something that I don't need to worry about. Now what I do is I take the fact that I have eliminated h from my question and I go up to my ratios and any one of those three with a h in it is not going to be relevant. So I am left with this one. And I write it out and I say tan of theta equals the opposite side divided by the adjacent side. I just write it out like that, so I remember. Okay? I did put brackets, but we didn't before, so we could just say tan of theta equals that. Now what I do is I put in the numbers I've got. So I know that tan of 36 degrees is equal to x divided by 8.7. Now you can see, if I get my numbers wrong, everything's going to be wrong, right? I have to identify those sides. How are you feeling about that so far?
Right.
Yes, Alex.
Why do you use that?
Because I crossed out the hypotenuse, I don't know it and I don't need it. The other two ratios include the hypotenuse.
Oh, right.
So I crossed them out because they had hypotenuse in them. Tangent, the toe of it, has no hypotenuse in it, so that's the one I can use. Yeah, that's why this is a good way. Also, having written all that down only takes 30 seconds when you get in the habit, and it's a good way of checking, did I do the right thing? All right, now we need to sort out this. First off, tan of 36. Do you know what that number is? On your calculator, right, let's see if I can get mine open. I have one that's a version of yours. So you press your tangent button, and then you type in 36 and press it.
0.72.
Have you got the answer already? Is everyone sure what you're doing? I need to. So tan of 36 is 0.726 5 4 2. Okay, we'll stop there. I've gone for a few because I've looked at my answer and it's got to be 3 significant figures. Now, that number is that. Tan of 36 is what that ratio, this ratio, needs to equal. So I can say that that side divided by 8.7 needs to equal this number. Okay. So how do I figure out what the x is going to be? So it's x divided by 8.7 is equal to that. So basic algebra.
Wait, you divided 0.726 by 8.7 to find x?
No, not quite. Right. This is x divided by that. So what we have to do is multiply both sides by 8.7. Okay? That gets rid of the division bit on that side and leaves me with x. So on this side it's 8.7 times that, and we get, over to you. 6.3209. Let's stop there. I need 3. So my answer will be, x is the side BC, so BC is going to be 6.32. Just that. Centimetres. Again, just like Pythagoras' theorem, I'm going to go up here and I'm going to put it in as 6.32, and I'm going to ask myself, does that make sense? This is 8.7, 6.32. That right, yeah? I don't know what the hypotenuse is, but at least it's not 63. If I did something like that, I might go wrong. So, lots of setting it up to get to the right answer there. Right, all good? Alright. Again, I'm going to be using those ratios, so I will be writing out, is it the sine ratio? Is it the cosine ratio, or is it the tangent ratio that I need? So I first got to decide, right? Well, actually, let's do something slightly different here. The angle is 60. So, just over here, sine of 60 is what? Do it on your calculator. Everyone. Cosine of 60 is?
0.86.
So 0.86.
6. 0.
0.
25.
25 and so on. Cosine of 60?
0.96. Oh, 60.
Cosine of 60? Sienna, what are you doing?
0.5.
0.5? And the tangent of 60?
1.732.
1.732. So, just to explain then, the ratios of these sides, regardless of what they are, only because that angle is 60, they will always be that. Alright, so I can use one of those numbers to work out these sides. It's just about which one do I use. So I'm going to write, well, theta being 60 is already, we've dealt with that, we've got these numbers. But do I know the opposite, the adjacent, or the hypotenuse? So the opposite is x again. The adjacent is? Do I need it? Don't need it, don't want it, cross it out. This is the hypotenuse, so that is 32. Now, which ratio do I use? Well, if I look at opposite over hypotenuse, those are the ones I've got. Anything with an A in it, I cross those out. So I know that I am going to be using the sine of theta equals the opposite side divided by hypotenuse to help me work stuff out. Because, look, it says calculate x. X is this one. Do I know this number? Do I want to work it out? Have I been asked to work it out? It's asking me to work this one out. So this is the one I want to know. This is the one I do know. This one, got nothing to do with it at the moment, is it? Now, sometimes we get more information than we need. We might know everything, and we've got lots of options. But at the moment, the A, this side here, the adjacent side, I don't care about it, and I don't know it. So I've crossed it out, therefore I've crossed those out. So now I'm going to do the sine of 60 is equal to, opposite is x divided by h is 32. I now already know that the sine of 60 is 0.86025. That equals x divided by 32. How do I work out x?
So 32 and then 32 or 32 times x and then 32.
So I need to times this side by 32. That gets rid of it from that side and leaves me with only x. But on this side, I also need to do 32 times that. And what do I get? What do you get? 27.7. Okay, that'll do. So three significant figures. X equals 27.7. Okay. Again, I'm going to put it up here, 27.7 centimetres. That's 32 and it's longest, so that looks pretty good. Alright. Okay. I'm just going to have to set your homework, so if you need to write this down with the video, so I can pick one for you. Yeah. So you can just do the next question for homework, question 3. So when's that for? Thursday? Yeah. Remember to try and set it out like I just did. Yeah?